இது கொஞ்சம் நீ இதை கற்றுக்கோங்கப்பா. நான் வரதுக்குள்ள கொஞ்சம் செட் பண்ணி வச்சிட்டீங்கன்னா டைம் சேவ் ஆகும். ஒரு 10 minutes ஆகட்டும், ப்ராப்ளம் பண்ணிட்டு வரேன். ஸோ on a issue. Okay. This one, yeah. So yesterday we did a problem, right, based on electric flux, that cylinder-based problem, right? That was the last one that we did. Now we'll do another problem from your textbook itself. It's example 11. Okay. So the question is like this. So listen, there is a cube of side A, right, that is placed in this way. There is a cube of side A that is placed in this way, where the first face of the cube is at a distance A. See, this part is not given in the textbook, that is missing, but it is at a distance A from the origin, right? Now, this whole cube is placed in the presence of an electric field in such a way that the electric field is behaving according to the function Ex is equal to alpha into x power half, and Ey and Ez are zeros, meaning the electric field is confined only to x direction, right? Now, having said this, if you observe, there is an electric field which is a function of alpha into x power half. Definitely it is not a uniform field, at least in terms of magnitude. In terms of direction, yes it is, right? Now, if I look at this diagram, right, since this distance is A from the origin, then what is going to be the coordinate of this point? This will be A comma 0 comma 0. Then what will be the coordinate of this point? It will be 2A comma 0 comma 0. Right? It is 2A comma 0 comma 0. Since electric field is varying as a function of x, what is going to be the value of electric field near the first face? So what is going to be the value of electric field along the x direction at the first face? It is going to be alpha into, in the place of x, I'm supposed to substitute A. So alpha into A power half. Similarly, the same electric field along x direction at face number 2, I'll take this as the face number 2, is going to be how much? It's going to be alpha into, now you know the answer. What is the x coordinate? It is 2A. So alpha into 2A raised to the power of half. Simple, right? Now, for the first side, area is going to be A square, which is oriented in this direction. Why is it so? Because it is outward. Whereas for the second phase, though the area is going to be A square, it is going to be oriented in the rightward direction because that is the outward direction. Now, since electric field is confined only to x direction, see what is going to happen is, if I take this as the third phase, the bottom as the third phase, the top I'll take it as the fourth phase. The one which is coming towards us is the fifth phase, and the one which is at the back is considered to be the sixth phase. Right? Now, this is how the structure is going to be. What is going to be the value of the flux through the first surface? So value of flux through the first surface is going to be E vector dot A vector. So what is the value of E? It is alpha into A power half. What is the value of A? It is A square into cos of electric field is in the rightward direction. aerial vector is in the leftward direction. So cos of 180 degrees. That is going to be cos of 180. Similarly, what is going to be the flux through the second phase? If I use the same formula, E vector dot A vector, how much is it going to be? It's going to be alpha into, it is 2a raised to the power half multiplied with the same a square, but it is going to be cos 0. So remember, wherever you have cos 180, the final answer will be negative. So whenever you say flux is a negative value, it signifies that the electric field lines are and leaving the surface. I'm sorry, electric field lines are entering the surface, right? Only when it enters the surface, aerial vector will be in the outward direction. So I repeat it, whenever the flux is negative, it means that the electric field lines are entering the surface. Whenever the flux is positive, it means they are leaving the surface. Okay. Now, phi 1 and phi 2 are like this. What about phi 3? Phi 3 is going to be, understand, the only electric field is along the x direction. For third surface, this is the direction of aerial vector. So this is electric field, this is the direction of aerial vector. Angle is 90, so cos 90 is 0. So phi 3 is going to be 0. What about the flux through the fourth surface? Aerial vector is upward, electric field is like this. Again a 0. This is the same as the fourth. Similarly, for the fifth side, the aerial vector is like this, electric field is like this. Again, it is a 0. And the same is the case with the sixth phase as well. So how many phases are having the flux? So it is, the flux is generated only through the first phase and the second phase, right? Now what are they asking? Calculate the flux through the cube. So flux through the cube is going to be flux through the first surface plus second plus so on till 6. So what is the flux through the first surface? If you observe, it is alpha into a power half into a square. It is a power 5 by 2. Right? A power half into a square is a power 5 by 2. Cos 180 is minus 1. Plus alpha into 2 power half, I can take it as root 2. So root 2 times alpha. Again, I have a power half into a square, which is going to give me a power 5 by 2. This time cos 0, which is going to be 1. So what is the common multiplication factor between both? So it is alpha a power 5 by 2 multiplied with root 2 minus 1. So this is going to be the value of the flux that is coming out through this cube. Right. So that is the first part of the question, flux through the cube. Only thing is you need to substitute the value of alpha here and the value of A here. I think A is 0.1. Yeah. A is 0.1 meter, substitute it there and then calculate it. Okay. That is one way. That is the way you solve the first one. What about the second part? The charge which is present inside the cube. Right. So once you know the flux, then we know that total flux is equal to charge enclosed divided by epsilon naught. So if you want the charge enclosed, take this flux, just multiply it with epsilon naught. So answer is going to be alpha into a power 5 by 2 into epsilon naught multiplied with root 2 minus 1. So this is the answer. So this is going to be the total charge that is present. Am I clear with this? Right. So now you can make a note of this. Some constant. Buboran. அது 16ல வைக்காதீங்க 23 24ல வைங்க அது கோத்ரேஜ் அதோட ரிமோட் எங்க இருக்கு பாஸ்கர் கேளு 23ல வைங்க 23 24ல வச்சா சரியான ஏசி அது கூல் நல்லா இருக்கும் அதுதான் நீங்க முடிச்சிட்டியா அப்புறம் எப்படி அதை செட் பண்ணாங்க 23 அவருக்கு ராஜேஷ் கால் போட்டு எப்படி மாத்திரம்னு கேட்டேன் அது வேஸ்ட் ஓடி கூட 16ல கூல் ஆகாது ஒரு கால் போட்டு என்ன ஆப் டவுன்லோட் பண்ணி ஏசியை கண்ட்ரோல் பண்ண முடியும் டவுட்டா இந்த கிடைச்சிருச்சு இந்த 24 batch right shall we move to the next one so this is the problem we did yesterday so shall we go to the exercise problems you're still copying doubt from where they have given it no yeah they have given no alpha into x power half depending on the charge if it is positive charge it is to the right if it is negative charge it is to the left okay so this is the first problem from exercise these are all very you are still copying yeah why you are so slow ஒரு ஃபோன் வச்சுக்கோ போட்டோ எடுத்துரு முடியுதா I think I need to have a phone here. One minute. Yeah, shall we proceed? Yeah, so look at this problem. What is the force between two small charged spheres having charges 2 into 10 power minus 7 coulomb and 3 into 10 power minus 7 coulomb, which are separated 30 centimeter apart in air? So it's a very simple problem. So what is given? So Q1 is 2 into 10 power minus 7 coulomb. Q2 is 3 into 10 power minus 7 coulomb, right? And what is the distance of separation between them? It is given as 30 centimeter. So 30 into 10 power minus 2 meter, right? And they separated the air medium. So what is going to be the force here? F is equal to 1 divided by 4 pi epsilon naught Q1 Q2 the whole divided by R square, right? So F will be equal to 1 by 4 pi epsilon naught is going to be 9 into 10 power 9 into Q1 Q2 is 2 into 10 power minus 7 into 3 into 10 power minus 7 the whole divided by R square. R square is so 30 into 10 power minus 2, or I can write it as 3 into 10 power minus 1. Right, both are same. So R square means 3 square is 9 into 10 power minus 1 the whole square is going to be 10 power minus 2. Right. This 9 and 9 will get cancelled. So 2 into 3 is going to be 6. Right. So 6 into 10 power 9 into 10 power minus 14 is 10 power minus 5. So 10 power minus 5 and this 10 power minus 2 will go to the numerator. So 10 power minus 5 into 10 power 2. It is going to be 10 power minus 3. So the answer is going to be 6 into 10 power minus 3 Newton. Here. Then the projectile. Is it direct as said last time? 33rd your mission. 440 because it take at least 10 minutes for me to explain. Shall I proceed? Now see. The next one is also simple. The electrostatic force on a small sphere of charge 0.4 microcoulomb, which is going to be 0.4 into 10 power minus 6 coulomb, to another sphere of charge minus 0.8 microcoulomb in air is given as 0.2 Newton. So in this problem, what is given? Force is given as 0.2 Newton. And what are the charges which are participating? Q1 is 0.4 microcoulomb and Q2 is going to be negative of 0.8 microcoulomb. Clear? So what is the distance between the spheres? So problem is simple again. F is equal to 1 divided by 4 pi epsilon naught into Q1 Q2 divided by R square. Okay. So force is 0.2 is equal to 1 by 4 pi epsilon naught is 9 into 10 power 9 into Q1 into Q2. Here see, I'm only taking the magnitudes. I'm not taking the sign into consideration. By looking at the problem, can you tell me, is it going to be attractive or repulsive force? Obviously attractive, right? So if I don't take the sign into consideration, it is going to be 0.4 into 10 power minus 6 multiplied with 0.8 into 10 power minus 6, the whole divided by R square, right? So if you observe this, can I write it as 2 into 10 power minus 1? Don't deal with decimals, deal with exponents. So 2 into 10 power minus 1 is equal to 9 into 10 power 9 into 10 power minus 12. 10 power minus 3 into this, I can write it as 4 into 10 power minus 1. And this I can write it as 8 into 10 power minus 1. The whole divided by R square. Make sense? Now, this 2 will cancel this 4 twice. I'll take this R square to the other side, 10 power minus 1 to the right hand side. So if I do that, what I'm going to get is R square will be equal to, I'm not going to multiply anything, observe, 9 into, this is the only thing I'm going to multiply. 8 into 2 is going to be 16 into, this 10 power minus 1 also cancels. Okay. So what is that we are left out with? 10 power minus, right? So R square is this, means R will be equal to square root of all these values. Square root of 9 is 3. Square root of 16 is 4, right? into square root of 10 power minus 4 is 10 power minus 2. So it is going to be 12 into 10 power minus 2 meter, or it is going to be 12 centimeter. So if you place them 12 centimeter apart, you will be able to see this. Right? So make a note of this. Now the next part is, see, let's finish this also. What is the force on the second sphere due to the first? Obviously, it's 0.2 Newton. Right. So make a note of this. Most of these problems you would have found in assignments, right? Because all were NCERT problems only that were given. I didn't give anything outside. Okay. What is the problem number? 33 or 23? 33, no? Next one. Yeah. So check that the ratio of K square divided by G times ME into MP is dimensionless. Look up a table for physical constants and determine the values of this ratio. What does the ratio signify? Okay. If you observe, right, let's say I have an electron and a proton. Let's say they both are separated by a distance r. Right. So one thing that is to be remembered is electron has a mass, let's say MeA as of now, and proton has mass MP, and electrons charge is E, protons charge is also going to be E. Am I right? Now, due to their masses and the distance of separation, they will experience a gravitational force of G into mass of electron into mass of proton divided by R square. And due to their charges, they will experience an electrostatic force of K into E square divided by R square. Am I right? Now, if I divide both, if it is going to be Fe divided by Fg, then it is going to be Ke square divided by G times Me into Mp. Right? So if you observe, this is the physical constant that they have asked. So what is it going to be? It is going to be the ratio of force by force, which is obviously a dimensionless quantity. So it is dimensionless because of what reason? Because it is the ratio of the same physical quantity. Okay. Now we look at the table and take all the values of these physical constants and substitute it here, we'll get a value. So for example, K is how much? 9 into 10 power 9. Charge of electron and proton is 1.6 into 10 power minus 19 coulomb. G is going to be 6.67 into 10 power minus 11. Mass of electron is going to be 9.1 into 10 power minus 31 kilogram. Mass of proton is going to be 1.67 into 10 power minus 27 kilogram. Right? This is how it is found. When you substitute all these values, you can observe that the electrostatic force is going to be 10 power 40 times the gravitational force. It's approximately that value. 10 power 39 or 10 power 40 will come. So the meaning of this is, right? So the ratio value is somewhere around this. The last part of the question is, what does the ratio signify? What is that you're able to understand? That the electrostatic force is approximately 10 power 40 times greater than the gravitational force. Is that point clear? So this is all about this question. So make a note of it. No need. Task you don't mention it. They won't ask you anymore. Am I clear? Right. So let's see the 33rd problem and then come back to this. Okay. Done copying? Yeah. Check if you're able to see that question. I don't think it will be there. Because for CBSE, you need not do the additional problems. Yeah. Tell me, what is that question? Can you give me the textbook? 33rd, I think. So page number 50. .33, right? So a particle of mass m and charge minus q enters a region between two charge plates, right? Initially moving along x-axis with a speed vx, like the particle shown in figure 1.33. Where is 1.33? So this figure, that is in question number 14. In question number 14, they have shown, no? So that is how there is a particle of mass m and charge minus q, which is moving between two plates, right? The length of the plate is L and a uniform electric field E is maintained between the plates. Show that the vertical deflection of the particle at the far edge of the plate is given by this value, which is QEL square divided by 2m into Vx square. Okay, let's try to break this question into smaller parts and observe. So what is happening here is, there are two plates. Okay. So let's say there is a positive plate, there is a negative plate. And there is a particle of mass m and charge how much? Minus q, which is present. It's not the coordinate, these are the properties of it, right? So it is given an initial velocity of vx, which is the velocity along the x direction. Now tell me one thing, you have a positive plate and negative plate here. How is the electric field going to be? Electric field is from the positive terminal to the negative terminal. It is going to be like this. So let me call this as E, right? Okay. So this distance is given as L, right? Now the important question is, when you have electric field like this, right? When you release this particle, then how is this particle going to travel? Is what the question is. So listen to this very carefully. I just want to tell you something important. If I have the electric field present in this way, okay, I'll use another slide. See, if at all I have electric field present in this way, there are different possibilities where if you place a charged particle in electric field, what do I mean by place? Means it is at rest. So if the velocity of the particle is zero, listen to this carefully. If the velocity of the particle is zero and you place it in the presence of an electric field, it will experience a force. It will experience a force of how much value? It will experience a force of Q into E, which is going to be in the direction of electric field, right? If Q is positive, else opposite direction. Means if the charge is negative, it will experience a force in the opposite direction. Okay, that is fine. Next thing is, I can give a velocity to this particle. If I give velocity to this particle, what will happen? It will still experience a force either in the direction of electric field or in the direction opposite to electric field. Right? How did I give the velocity here? I gave the velocity along the electric field. Now comes the challenge. What if I make the electric field vertical like this, but give velocity to this particle, but in the perpendicular direction? As soon as it enters the field, what will happen is, it is already having its own velocity, due to which it will tend to move in the horizontal direction. But due to the electric field, it will experience a force in the upward direction, as a result of which it will start bending in a curved path. Now the question is, what is the curved path it is going to take? And the curved path is going to be a, any guess? What is the curved path going to be? Okay, but what is going to be the shape of the curved path? It will be, is it parabola or circular? It is parabolic. So make a note of this, because the similar kind of concept comes in electric field also. There it will not be parabolic, it will be something else, because there is a reason for it. Okay. So what is happening here? I hope you understood the whole story. When you talk about electric field, you have nothing to do whether the charge is placed, whether the charge is given velocity or not. It will move in the electric field. Right. Only thing is, if you place it, it is going to experience a force. If you give it initial velocity in the direction of electric field or in direction of the direction opposite to electric field, it will still experience force, but it will move in the same direction. Whereas if the electric field and the initial velocity are perpendicular to each other, what path will it take? It will take a parabolic. Okay. So this is a very, very important point to be noted. Clear with this? Right. Now, what do we have to do with this problem? If you observe, what will happen? You have a negatively charged particle, and the electric field is from the positive to the negative terminal. So, as soon as it enters the electric field, right, exactly perpendicular to it, what will be the path it will take? It will take a parabolic path. The parabolic path would either be in the upward direction or in the downward direction. In this scenario, how will it take? It would have taken in the downward direction had it been a positive charge. Here it is negative charge. What will happen is I released it at the negative end. So it will repel due to the negative charge and it will take this kind of a path. Now, if you see the question, what they are exactly asking is, what is the vertical displacement that has taken place? What is the vertical displacement that has taken place at the other end? That's what they have asked, no? What is the vertical deflection? So how much has it got deflected from its initial position? Means our job is to find the value of y. It's very simple. Okay, whenever you have these kind of problems, right, where you're asked to find the displacement, use the equations of motion. What does it state? S is equal to ut plus half at square. So apply this initially along x direction. Sx is equal to ux into t plus half into ax into t square. What is the displacement that has taken place along the x direction? L is equal to, what is the initial velocity along x direction? They have given it. Vx into t plus, in this scenario, remember the particle will experience force only in the direction of electric field or in the direction opposite to electric field, right? All other directions, the force experience is going to be zero. When force is zero, acceleration is also zero. So electric field is confined to which direction? X direction or y direction? Y direction. So the acceleration along x direction is going to be a zero, right? So from this, can I say t is equal to L divided by Vx? Let me call this as 1. Similarly, if I apply the displacement along y direction, so Sy is equal to Uy into t plus half into Ay into t square. So what is the displacement along y direction? It is y is equal to, what is the initial velocity along y direction? 0, because it's given only along x. 0 into t plus half into, what is the acceleration along y direction? See, charge is there, electric field is there. What is the force experienced by the particle? Q into E in terms of magnitude, right? But we also know that force is equal to mass into acceleration. So what is going to be the acceleration along y direction? It is going to be Q into E divided by M. But here, yeah, Q is Q only. So take it and substitute it here. So it is going to be Q into E divided by M into T square. In the place of T square, I can substitute this L divided by Vx, the whole square. So what is the answer? Y is equal to QE L square divided by 2M Vx square. If I'm not wrong, that is what they asked. Is that not the expression? That's it. Clear? Done with this problem? Done? Okay. See, the first 12 to 14 problems are easy only. You yourself can do it. 15th onwards, I'll do it, which are based on flux. Okay. Shall I proceed? Yeah. Okay. Listen. So consider a uniform electric field of value, how much? 3 into 10 power 3 I cap Newton per Coulomb. What is the flux of this field through a square of 10 centimeter on a side whose plane is parallel to the YZ plane? So how to solve this? So what is the flux of this field through a square? So there is a square of 10 centimeter on a side whose plane is parallel to YZ plane. Meaning? Okay. See, this is x-axis, y-axis, z-axis. Whose plane is parallel to YZ plane means it is something like this. Okay. This is y, this is z. So this is the YZ plane, and this is how the electric field is. So whenever a plane is parallel to YZ plane, right, what will be the direction of its aerial vector? See, it's very simple. X-axis, y-axis, z-axis. So if they say YZ plane, right, if any shape is confined to that particular plane, its aerial vector will be in this direction. Similarly, if I say something is confined to XY plane, then its aerial vector will be in the Z direction. That's it. It's very simple. Right. So in this case, aerial vector is going to be equal to 10 into 10 power minus 2 the whole square, because a square times I cap. Right. It's going to be in terms of meter square. So what is going to be the answer? 10 into 10 power minus 2 is 10 power minus 1. 10 power minus 1 the whole square is going to be 10 power minus 2 times I cap meter square. So what is going to be the flux? It is going to be E vector dot A vector. Multiply both. So 3 into 10 power 3 into 10 power minus 2. I cap dot I cap is going to give you a 1. Answer will be 3 into 10 power 1, which is going to be 30 Newton meter square per Coulomb. Am I clear with this? So what is the answer for the second one? What is the flux through the same square? You have the same square, right? But in this scenario, what is happening? If the normal to it, right, normal to its plane makes an angle of 60 degrees with the x-axis. So if this is going to be the x-axis, if this is going to be the normal, for instance, right? How is this normal? It is making 60 degrees with the x-axis, right? So this is going to be 60. Then how do you calculate the flux? Why 90 minus 60? See, this is the electric field, okay? And this is how the normal is. Normal makes, what is it? Square. If the normal to its plane makes an angle of 60 degrees, okay, tell me, huh? Why? Okay. See, how is a normal take? So this is the direction of electric field, no doubt in that. It is fixed, positive x direction, right? Now, how is the square? So are you taking it like this or like this? Like this. Okay, if you say this is going to be the normal for the, this is going to be the normal for the paper, and this is the x direction. How much is the angle between both? 60, right? Then why do you want to take 30, 90 minus 30? That's what, no? That's what you're supposed to do, no? But he's saying we should take 90 minus 60. Okay. So let's, if you draw it right, the square is going to look something like this. So this is going to be the aerial vector. So what did they say? What is the flux through the same square? The same square. If the normal to its plane. So this is the plane. And the normal to the plane is like this. Normal to the plane makes an angle of 60 degrees with the x-axis. Right? This is going to be the electric field. Now what is going to be the angle between both? 60 only. No, why do you need to take 30? Had they told the plane is making an angle 60, then you should take 90 minus 60. Did you solve this problem already? Similar to this, because you are just checking, there is another problem. Because as per the question, right, I'm just checking, is this the same thing? Am I understanding it wrong? Is this the same thing given in textbook? Can you check it once? The normal to its plane. So this is the plane. Normal to its plane is this thing only. Normal to the plane makes an angle of, correct only, makes an angle of 60 degree to the x-axis. Electric field is already aligned to x-axis. So it should be cos, it should, answer should be 15 only. What is the answer given at the back? Check it once. 1.15. 15 only, no? Because I was trying to see, there are two things. What you say, 90 minus will come. I'll tell you in what scenario it will come. In this problem, it will not come. I hope everybody is able to visualize what I'm trying to say. Right? Try to understand this language. This is where we'll get confused. The square is there. There are two normals we define. One is normal to the plane. One is the plane itself acting like a normal. Okay, so you need to be very careful. In this question, what they're saying is the square is there and the normal to, so initially it was like this. The previous, in case number A, it was like this. That is why what happened, we took I cap. Right, we should not forget that electric field is confined to x direction only. When they say normal to the plane is making 60 degree, I can either take it like this or like this. Both are same. I could have tilted it like this and kept. I could have told that this is the normal. Then also the angle would have been 60 only. But sometimes what will happen is they will say the square is perpendicular to it. Or the square, the plane of the square is making an angle 60 degree. So if this, see, this is how electric field is. If the plane of the square is making 60 degree now, it will rotate like this. Then the normal will not be 60, rather how much will it be? So it will change accordingly. So that is where we need to be careful, where to take that 90 minus and where not to take. In this problem, we need not take. Right. So how much is this going to be? 60 A. So EA cos 60. E is how much? 3 into 10 power 3 into A is 10 power minus 2 into cos 60 is half. So basically it should be half of this value. Actually, it's a simple problem only. So copy it fast now. Shall we proceed? Yeah. So how to solve this? What is the net flux of uniform electric field of exercise 1.15? That is the previous problem. Through a cube of 20 centimeter oriented so that the faces are parallel to the coordinate planes. So what is happening is in the previous case, it was only one square. Now there are 6 squares. And how are those 6 squares placed in the shape of a cube? And how are the faces oriented? They are parallel to the coordinate axis itself. So if you take them to be like this, x direction, y direction, z direction, this is going to be 0, 0, 0. And what is this point going to be? Okay, all these things are not needed. Only thing is, electric field is in this direction. How much is it? 3 into 10 power 3 I cap, right? So electric field is in this direction. And observe 1, 2, 3, 4. The one towards you is 5. The one away from you is 6. So the flux through the first surface, how much is it going to be? Flux through the first surface will be E into A into cos of 180. What is the flux through the second surface? E into A into cos of 0 degrees. I hope it is clear. Right. Flux through the third, fourth, fifth, and sixth is going to be 0. Right. And E and A is going to have the same value. We know that cos 180 and cos 0 have exactly opposite values. So when you write the total flux, what will happen? Phi 1 plus phi 2 plus so on till phi 6. Phi 1 is minus EA. Phi 2 is plus EA. Everything else is 0. Answer will be 0. What is the meaning of this? Meaning the number of electric field lines which are entering the surface is equal to the number of field lines which are leaving the surface. Right. Meaning this kind of a system, what will be the total charge which will be present inside? If at all the question is extended saying, what is the net charge that is placed within the cube? What will the answer be? 0. Because what does Gauss law state? Total flux is equal to charge enclosed by epsilon naught. Total flux itself is 0. Charge enclosed will be 0. 5, 5. Okay. right? So yeah, so there are 5 to 6 more problems which we need to do based on clubs. I'll do it in the first 20 minutes in tomorrow's class, and then we'll start off the next chapter. See, I just wanted a quick, I just wanted to ask a quick question. Like, tell me one thing. Like, see, as I told you in the beginning, right? I want to solve more problems in the class. So for that, I feel the best way is you can work on the pre-recorded. You can see the pre-recorded videos and come to the class, and we can concentrate here more on problems. There are two things I feel from my side. I'll just tell my opinion. You guys tell me if that will help you. Okay. So one thing is the concept part. You can learn it anywhere, but I'll be teaching. I'm not saying I'm not going to do it. Instead of me doing it in the class, right? If I give you the pre-recorded versions, are you guys ready to work along with me to ensure that you learn those things before coming to the class so that we can focus on problems at a faster rate? Because I want to solve one big problem, that is I'm not able to solve assertion reason based questions or case study based questions. I'm not able to go. We're still stuck with NCERT because for the past 6 class, I had been teaching concepts, right? So I feel there will be a slight delay because of this, because we'll be completing the syllabus only after October or something. After that, your record works and everything will start, which will put so much of pressure on you. I am seeing that you should be ready by September, because after that you will have your annual day thing, sports day, all these things will get disturbed. Then you will have a lot of record pressure also. Trust me, I've been saying this for years. But I want your opinion. Don't accept it for me. But are you all comfortable with this kind of a pattern? Will you be able to work at home along with me so that we can concentrate more on problems? It will, first 4 months, we need to work like that. There is no other option. Because one thing, each one of you is taking different time to copy the notes, due to which I cannot teach more than 2 or 3 subtopics. Whereas if I give you recordings of 4 subtopics in a day, you can watch at your convenience, you can rewind it as many times as you. In spite of it, if you have doubts, I'll definitely clear it in the class. I'm not saying I'm not going to do it, but I feel that will work. But what is your opinion? Will that work? How many of you are okay with it? Don't look at each other's face. You tell me your opinion. Which one is more convenient for you? You want me to do more of problems or teach more of theory? Problems, right? So you need more of help for exam, right? That is the reason why you're coming here. Right? If that is the case, then we have to start slowly working on that kind of a format. Will that work? Yes. Right? So we'll try and see. So if there is any difficulty, you can reach out to me personally and telling what is there. Okay. So next chapter I'll slowly start, but from next week onwards, we'll try that pattern and see. I'll give you some pre-recorded content. You work, you study at home and come. But even if one content you are not able to see and you're coming to the class, it will be difficult. So you need to be in track with whatever I'm doing. Is that clear? That is the only challenging part. Else, trust me, that is the most comfort way you can learn. Okay. Okay. We'll try that and see. So I just wanted to ask. Okay. So the remaining problems, I'll solve it in the next class. I'll see you all. சொல்றேன். பென் டிரைவா இருக்கலாம்.